Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video I want to talk about some examples of the three trigonometric functions that we talked about in the previous video, specifically sine, cosine, and tangent, relative to the two angles that we have in this triangle down here. We have this angle here which we called theta, so we'll say theta. And then we had this angle up here, which we called phi. Right, so we have theta and we have phi. And we want to calculate the sine, the cosine, and the tangent, given this triangle here with side lengths 4, 3, and 5. So let's start off with the angle theta here. And let's go through sine, cosine, and tangent. So again, that SOHCAHTOA, right? SOHCAHTOA. This is going to help us figure out what sides we need to use to calculate our sine, cosine, and tangent. So let's start with the sine of theta. So the sine of theta is going to be so opposite over hypotenuse, relative to theta, which is this angle right here. The opposite is 3, right? Because this side does not touch the angle. That makes it the opposite side. And then the hypotenuse is always the side opposite the right angle. This is our right angle right here. So this is the hypotenuse. So is opposite over hypotenuse. So the sine of theta in this case is going to be 3 over 5. The cosine, so ca, adjacent over hypotenuse. The adjacent angle is going to be 4. The adjacent side is going to be 4 because that's the side that touches the angle. And again, the hypotenuse is still 5. So in this case, the cosine is going to be 4 over 5. And then finally, tan, which is the TOA, which is opposite over adjacent. So the opposite, again, of theta is going to be 3, just like before. And the adjacent is going to be 4, just like before. So the TOA, or the tan, is going to be 3 over 4. Okay? Hopefully that made sense. Again, this was relative to theta, but we have a second angle. We have phi, right? Because the triangle has 3 angles. And in this case, because it's a right triangle, we have this 90-degree angle here. But we have 2 others. We already did theta. What about phi? What changes for phi? We're still going to use SOHCAHTOA, right? We haven't changed our definitions of sine, cosine, and tangent. We've just changed the angle that we're looking at, right? We've changed the angle that we're looking at. So we have phi here. So let's talk about sine, right? So it's opposite over hypotenuse. Well, what side is opposite of phi? Right? Again, opposite is the side that does not touch the angle. So in this case, with phi, the opposite side is going to be 4 down here. So the sine of 4, the opposite part, the sine of phi, the opposite part is going to be 4, right? And then the hypotenuse, right? The hypotenuse doesn't change because the hypotenuse is always the side opposite the 90-degree angle. So in this case, the hypotenuse is still 5. So we have 4/5. The ka for phi is adjacent over hypotenuse again. So again, what angle is adjacent to phi? Well, this is going to be this length side 3, right? This length side 3 here is adjacent to phi because this side is the one that is touching phi. So the adjacent side here is going to be 3. And then the hypotenuse, again, never changes. So it is going to be 5. Okay. What about TOA? What about the tangent, right? Opposite over adjacent, right? That's what the O and the A stand for. So if we look at this, right, the opposite side of phi is still 4. And the adjacent side to phi is still 3. So opposite over adjacent is going to be 4 over 3. Right? So hopefully that made sense. Again, SOHCAHTOA is your best friend here, and just keep in mind relative to what angle you're talking about. Because we had two angles, we had theta and we had phi, and you can see how the numbers changed depending on which angle you were talking about. So again, SOHCAHTOA and keep track of your angle. If any of this didn't make sense, please reach out. Thank you.